Okay, so first of all, from the question you can see is y equals minus x, so as you guys probably know already, it's just a line going through there.
It is. Can anyone explain why it's that line going through there, Lewis?
I can't explain it, but just you know how to like do it. Do a table with like.
Very good. Yeah, you could write the graph you wanted to, and y equals x is the x value is the same as y value. So 1 and 1, 2 and 2, 3 and 3, 4 and 4. Minus x is just you flip it round. It's the mirror image of that. Very good. Well done. These ones are notoriously done very badly. Just to warn you, it wouldn't surprise you if Josh is just testing you and he puts it down wrong to begin with. But you may just be straight into what the correct answer is. If he does what he does, he's the fine. But I see this done all the time wrong. Like people like draw a triangle like that there, they rotate it round. It's nothing. It's what you've done, Josh. Yours is fine. Can you talk us through how you do it as well?
So you can do it a number of ways. Like from the first question, you can like go from a point and count how many you go up and up. You can do it that way, or you can just do it so how many times it goes up. So 1, 2, 3, 4, 5, 6, 7, 8. So that goes up 8. So then you know it goes across 8. So 1, 2, 3, 4, 5, 6, 7, 8.
That's exactly the same way I do it as well. You count up, it hits the line, because diagonally it goes the opposite directions, like beam of light hitting something, it would then hit it and then go that way, wouldn't it? So
then from here, instead of doing that process again, I know from that point is equal to that point, so we need to go back 2. So it goes back 2 and then down 4. By there, then just line it up.
And you know the tracing paper way of doing it?
Yeah.
If you trace the original and the line, and then you flip over the tracing paper, and you match the line up, it should match up with it. It's a great way for checking, but that's perfect. Okay, that's really good. And again, if I went and checked here, from this point here, 1, 2, 3, 4, 5, 6 points. 1, 2, 3, 4, 5, 6 points is absolutely fine. Grant.
We get tracing paper.
You do get tracing paper. It will be given to you in the exam. Okay, if it's not, get your hand up and ask for it because it's supposed to be there with your paper. Okay? All good? Any other questions? Good question. And do you want to do the last bit for me as well?
Oh yeah, so do we have
some
to
people, you don't have to, some people can do it and it genuinely mind blows me. Every time I see someone doing that tracing paper, I have to have tracing paper to do this. I find it very hard, especially if it's not the origin, to do it without tracing paper. But some people can.
Okay, so from we look at the question, we can see 90 degrees, we see anti-clockwise, so that means we go around that way, yeah. And always look to see what the point of origin is.
Now, careful with what you said. What you said is correct in terms of what I know you're talking about. Go and mark what you're about to mark. Go and do what you're about to do.
So I go -2 across, -4 down. So there's...
Okay,
not the origin, it's the point of rotation.
Excellent. The origin is what? It's a very specific point of the origin. 0, 0. Okay, so it's the point of rotation, but you correct yourself, it's fine. Okay. I'll show you something that I do as a trick as well. Not many people know this. I'll show you on the board. If you want to do it to yours, by all means do. If you go and draw a crosshair through there, and then you actually trace the shape and draw the crosshair again, you split into 90, 180, 270 and 360 every time it crosses over itself once. It's quite a clever way of doing it just to see where those rotations are. You don't have to do it, but I find it very, very, very useful when I do it. Okay, go on then.
Okay.
You're not even going to use tracing paper, are you?
No, so
I'll show you then after.
from the point, I go down 3, so anti-clockwise, so I'm going this way. So I have to go across 3, so there's the point, and I can tell that, because it's rotated 90 degrees the other way, that the shape will be that.
Is there who's finding that method quite hard?
I done it wrong.
I love the way you said it, I can just tell, because I can't, I genuinely can't. I don't look at that and go, oh right, obviously no. Some people do, for some of us we don't. I'll show you the way I do it just to sort of back it up as well, what I do. But I love that, thanks very much Josh, I find that really interesting. Do you want to show you the bit that it definitely is?
Oh yeah, I've done that bit wrong, so
just show you the triangle that is there.
So it should be...
And now in an exam, that's showing me what you meant, okay? I definitely
this
marked
triangle.
that correctly, okay? Okay, so if it was me, what I would do... Thanks, Josh. Well done. Is that your pencil as well?
Yeah.
Do you have my pencil, David, or do I grab it back off you?
I'll give it back to you.
You lend me a pencil? I seem to have misplaced it. You got one? Thanks, Amy. Okay, so what I would do here, where he said I'll mark the point of rotation, I actually go and draw this crosshair like that on it. And the reason why I do that is so when I get the tracing paper and trace the shape, trace that, you keep your pencil on that, and then every time it crosses on itself once, it's done full 90 degrees. So if I kept it on there, next time it crosses, that's 180. Next time it crosses, that's 270. And then the third time. And then even if you've come slightly off where your pencil was, because I know it was supposed to be fitting on itself once, I can just go and fit it up there. So that would be 180 again. Then here would be 90 again. Okay, so I find that quite a useful way. Okay then, so that's transformations done. Thank you for Josh for those. So, don't like question 6 coming up, just to warn you. Okay, so there. Okay, and so I guess the reason why that's here, thanks very much, Amy. I guess the reason why number 15 is here is because we've got to do it in our head, we've got to do it mentally. I don't think it's a particularly hard question. I'd say that we've come out of the A star stuff now. So we've got y is equal to 4x cubed minus 12x squared for the values of minus 1 to 3. So here, x is equal to minus 1, so y would be equal to, and what I'm going to do is what we did right at the start when Paul did it, I'm going to keep the minus 1 in brackets, so cubed, and then minus 12, lots of minus 1 squared. Minus 1 squared is positive 1, minus 12 times positive 1 would be minus 12. And then minus 1 cubed would be minus 1 times minus 1, which would be positive 1. Times that by minus 1 would be back to minus 1. So this would be 4 times minus 1, which is minus 4. So y would equal minus 4 minus 12, which is minus 16. Is there a point for me to plot at minus 16?
Yeah.
Yeah, so I've probably done it right. If it comes out of these points, though, I've done something wrong, haven't I? Okay. Also, a cubic graph is going to look something like that. Okay, you should know that before. We've talked about that before in lessons. For the naught, they've already done that. Oh, for the 1, I'm hoping the 1 will be easy. That was the hard one that we just did. 1 would be 1 cubed is 1, minus 12 times 1. So that's going to be equal to 4 take away 12, which is minus 8.
Oh, sorry, minus 8.
All good? Yeah? Just check it's not me. Okay, so then go and plot these. So the first thing you need to do, your scale goes from goes in a gap of 5 there. So the scale is equal to that gap of 5 divided by how many little squares fit into this? 10. So each little square is worth 0.5. So minus 1 here, minus 15, so minus 16, 2 down from the minus 15. 0.5, sorry, minus 3.5. So 0.5 there, that would be minus 2.5, minus 3, minus 3.5. Then 0, 0. And then minus 2.5, so that's bang in the middle here. And then minus 8. So that's minus 10, that'd be minus 9, that'd be minus 8. And then 1.5 is minus 13.5. So minus 15, minus 14, minus 13.5. Minus 16. So again, back down to here. Minus 12.5, so that would be bang on here. And then back to 0. Okay, so look at that shape up here. Did you see me draw that earlier? Is that shape sort of replicated here?
Yeah.
Yeah. This should be a freehand sketch, and you should be doing everything in pencil. Okay, I'm doing it in pen. If it goes wrong, I'm absolutely screwed now in the actual GCSE paper. So it would come round, curve round like that. A little bit like our sine and cosine curves from the other day. Curve round, curve up. Just stop there at the ends like that. Just carry it going on there. Carry it going on down there. Okay. Yeah. It would be a very harsh mark to lose. I doubt it. I doubt it. So you're only looking at 3 marks there. Yeah, only the 1 and the 2 there. For the next bit, it says write down the coordinates where the gradient is 0. What does the gradient equal 0? What's that look like? Straight line. Going which way, Kellen? Tell me where. Horizontal. Fantastic answer. Okay. So a horizontal straight line. So that would be this point here. Yeah? And this point here, which is sort of already drawn with us at our axes. Okay? So that means it's that coordinate there, and that coordinate there.
Why wouldn't it be 3, 0?
3, 0.
Because that's gradient 0.
Well, if you look at where it is, what's the gradient of that line there? It's quite steep, isn't it, by here? Now, although the coordinate is 0, I totally agree with you, the coordinate is 0, that gradient there is quite clearly a steep gradient, isn't it? It's flying up. Okay, the gradient 0 is when it goes to being absolutely flat. So
Oh, and it goes like that.
Yeah. So
Okay.
gradient zeros are when it's like that. That make sense?
Yeah.
Good question, really good question. I hadn't even spotted that. So first set of coordinates are 0, 0, the origin, and this one here,
Minus
2 minus 16.
Yeah, 16.
And then it says, these ones here are always quite tricky. It says, when the line 8 minus 8x is drawn between 1 and 3x, it intersects the curve at one point. Use your graph to find the coordinates. So we're going to draw an xy table, so very similar to our shaded regions that we did recently as well. So y is equal to 8 minus 8x. What values of x am I going to use?
1, 2, 3.
Good, because
No.
we're told it's between 1, 2 and 3, aren't we, by here? Okay, so 8 times 1 is 8. 8 take away 8 is 0. 8 times 2 is 16. 8 take away 16 is minus 8. And then 3, 8 times 3 is 24. 8 take away 24 is minus 16. So now we need to go and plot those coordinates on here. So what have we got? 1 and 0. 2 and minus 8. Let's make sure you plot this correctly there. And then 3 and minus 16 was it? So that should be the case. Does it cross the curve in only one point in that line? Is that good news? Why?
Because it intersects the curves at 1 point.
Yeah, it tells us it crosses in one point. If it crossed in 2, I've done it wrong. Okay, if it didn't cross at all, I've definitely done it wrong. Okay, so what are the coordinates of that point? Up here, I believe it's roughly this one here, isn't it? From there? Yeah? So we're going to say x is 2.5, y is minus 12.5.
I said 2.5, 13.
Fine. Yeah, you'll be allowed to have like a bit of leeway on that. Okay, if you got that done on your own, well done. That's reasonably tricky without a calculator. You had to know all your graph stuff there. That's it, done. We're looking at 6 marks there. Quite big 6 marks.
So what's the gradient?
Gradient is how steep a line is. So if I go through this bit here, gradient here is a positive number because it's quite steep. But as soon as it starts slowing down here, you can see it's getting less steep here. That'll then be a fractional. Then as soon as it goes horizontal here, it's 0. Then it starts coming down here, so it's flat again, but it's going the other way. That'll be a negative fractional gradient. Then here, be quite steep, so -2, -3, something like that. Then here it's getting flat again, so negative fractional. 0 again, back to positive. Fractional, then really steep.
Would it be 0 again then? Or if it's still going up?
So flat here, it's only got 2 gradients of 0. Okay? All good? Need you to come up and do 5 and 6 for me?
Oh, can I do 5?
You can come up and do 5 then, Callum. 6 is hard one to explain.
Oh, I did 6. 6 is good.
Oh,
Yeah, I agree with Paul.
Draw a triangle there. Draw a triangle. Draw a triangle for this one.
Go on, Kellen.
Wait.
Scott.
So you're expanding the brackets here, so you times everything in the bracket by what's outside the bracket. So y times y to the 5 is y to the 6 because you add the indices. And then
If it hasn't got an indices,
if it hasn't got an indices, it's just 1. Plus 3y. And then the next one down, you've got to put it into brackets. So you find a common, what goes into both of them, which is 2x. So 2x goes.
It could be a number or a letter or both.
So 2x goes outside the brackets, and then you have to times 2x by 2x squared to get 4x cubed. And then 2x times 1 is 2x, so 1 goes in the brackets.
All good? Fantastic. Sticking on that page with there, thank you, Karen. I'll stick to the deal we made. Anyone want to go through 6? Go on then, Karan. I think 6 is hard. Coming from me, from a teacher, I've taught this a number of times, and people always find this one hard to get. Grades, C grade, believe it or not, but...
No.
Yeah, boy, you can use mine all right. I've got 2 going there.
Did you get it?
Why not if you watch it? Okay. I guess I have to watch it now. Yeah, everyone else will watch it now.
Alright. So it tells us that his friends won 1/24 of the money, and after they all took it, 2/3 remained. So whatever the money was, we'll just name that X, and his friends took 1/24 of the money. So the money which he had left was 2/3. So the money which his friends took was 1/3. If you get that.
Yeah.
So 1/24x is basically x over 24, which equals to 1/3. And then x equals to 1/3 times 24, which is 24 divided by 3, which is 8.
Yes.
That's a really clever way. I've never thought of it like that. I can go through it my way as well, but absolutely spot on. I really like it.
You can talk.
I'll just do. I don't really want to spoil Karan's work on there, so I'll just write it on the board by here. The way okay, 3, 2, and 1. Thank you. The way I always did this bit was I said that so 1/24 money. I highlighted the same thing. So if he's keeping 2/3 of it, then they must have had they had 1/3. Now if they're chucking that up in like 1/24s, then I need to get that in 24s. So I'd say make that into 24s. I've times that by 8. So I times that by 8. So that's telling that there are 8 24s. So if they're going out in 1/24 bits, then there must have been 8 friends. Okay, it's the same sort of idea. I quite like the way you turn that into an equation. I actually then solved it as an equation and said, look, x is 8. I like that idea. Okay, so I don't know if that's any use to anyone else. God, that is an advanced way. I think that is an advanced way, but I did like it. Very good. Okay, let's go back to go back to the back of the page.
Oh, the potato one. This one's so easy.
Oh, okay. I'm doing this for the attendant. This isn't too bad at all. I got an easy one. I'm quite pleased I've got this one. Okay then. Right, the key word here is... That's coming up in a moment. Keyword here is the nearest kilogram. That means it's been round to the nearest kilogram. This means it's a question on upper and lower bounds. Good, so you know what that is. Nearest kilogram means 1 kilogram. You divide that by 2 and you halve it to get 0.5 kilograms. So it says the bag of potatoes weighs 3 kilograms. So 3 kilograms could have been either 0.25 kilograms, 2.5 kilograms, or it could have been, that's what we call that is lower bound, or its upper bound, we would have added that on to get 3.5 kilograms. Happy with that idea?
Oh, that was 3.4.
Now, technically it is, but someone can go a bit further and say 3.49, so we say 3.499999, 3.49 reoccurring. And if you put 3.49 reoccurring into your calculator, press equals, it will come up and say 0.5. The idea that we write is we say that it could be between 2.5 kilograms, and we say that it could equal that, less than or equal to, but we say that it's less than 3.5. Okay, so it can't actually ever quite reach that. So this is like the floor of which you're definitely standing on. It will be, it could be that, but this is the ceiling. You actually never quite touch the ceiling. Does that make sense? Mm-hmm. Okay, so it says, and now the next most important word is at least. It says this. It says the sack contains 5 bags of potatoes. This sack of 5 bags contains at least what?
5 times 2.5.
5 times 2.5, because it said at least. Okay, so 5 times 2.5 would be 12.5 kilograms. Okay, all good?
Simple as. Can you do 13 just now? Because that was really easy. And I just didn't get 13.
13's hard. I do? Yeah. Sorry.
So we did 2 in the last one and the easy one, so I think we should do 2.
Just freeze that quickly. I can do 2.
We did. No, I don't remember some of this. Excuse me,
Good, Manny. Yeah. Good.
that wasn't inside.
1 second. Let me just. Oh, sorry.
Like Rob went. Yeah, she was like.
Okay, then, guys. 5, 4, 3, 2, and 1. Rachel. How did we get 12.5 then? What calculation do I do? 5 bags. They could weigh somewhere between 12.5 and 3.5. And it said at least. So the fact that it said at least, then I just do the lowest bag times by 5. Okay? Right then, guys, can I have a bit of quiet, please? Thank you. Still waiting. Thank you. Okay, I will go through number 13, as that one was quite quick, and this one is quite hard. Okay? Now, some people have just spotted this straight away. It's actually using, the main theory behind it is using a bit of C-grade maths, but they made it totally out of the C-grade boundary by putting in loads of other things like pi and h's and stuff like that. Anyone know what main theory is that we're using? I think Ed definitely knows. Go on. It is Pythag, yeah. So basically, you've got this cylinder here that if you cut open this card here, that would just be a straight line coming down like that.
Oh, that's
Okay.
so annoying.
It's like toilet roll. That's a great idea, yeah, because they go around in the curve as well, don't they? Yeah, it's just like toilet roll. Except toilet roll goes round like that, like a number of times, doesn't it? This is like the shortest. This is the shortest distance from here to here.
So they should have just said this is toilet roll.
This is toilet roll, yeah.
No, you
Okay.
still would have got it wrong. That wouldn't have.
It would have made sense. Sure.
Right then, the other hard thing about working out things here is what are the measurements. So, like for instance, if this is a cylinder, well, this is the height of the cylinder, isn't it? We're happy with that. So that distance there is going to be what?
The height.
The height. Okay, but what's this distance here to here going to be?
That's going to be
The circumference of the circle.
Very impressive, yeah. I had to actually see this mapped out for me, so I'll try and do it under the camera. I don't know if it'll work. Need someone with a steady hand to come and hold the camera above it. Let me try and do it here.
Luke doesn't have.
Is that working? It's harder than it looks, actually. Then if I've got a cylinder and I open it up into just a flat piece of paper, then that straight line there now is what the circumference was a moment ago. Do you see that? So this thing here, all the way around, that is now that straight line. What is that thing around the circumference? What is that formula that we use for circumference? Pi d or
Pi 2r.
2 pi r? Pi 2r? No, pi 2r is fine, David, as well. We tend to put the 2 up at the front, okay? I'm going to use, what are they telling me? They're telling me radius, so I'm going to use 2 pi r, okay? But pi d, man, is absolutely fine as well, especially if you've got measurements. So it says the cylinder has radius r, height h. Okay, right, I've dealt with that. I'm happy I've done that. I'm going to read the question because otherwise I'll probably miss a really important bit. It says the points P to Q are on the circumference of the opposite ends of the cylinder. Point P is vertically above point Q, so that's how I know that when I fold that around it will be straight above it. That's telling me it's making what sort of angle?
90 degrees.
90 degrees. By considering the net of the cylinder, find an expression for the shortest distance from P to Q when travelling around the cylinder. Give your expression in terms of pi, h and r. Okay, so to find that distance there, I've got a right angle triangle, I've got two sides. I know that 2 pi r squared, is that bringing up my writing? 2 pi r, now be careful, that's all of that squared, plus h squared would be equal to pq squared. All good?
No.
So that's coming from Pythagoras theorem.
Which
A squared plus B squared equals C squared.
What are we doing?
So right angle triangle.
Yeah.
I've got two sides and then I'm missing hypotenuse, okay?
Yeah.
So that squared
Oh.
plus this squared
Oh.
would equal this squared. So that's what I've
right,
written
okay, I
here.
get it now.
Okay, no, it's good. Ask questions if you're unsure. Was important. Right, 2 pi r times by 2 pi r. 2 times 2,
4
pi times pi,
pi squared
r times r.
r squared.
Okay, so that's hard, that bit. Plus h squared, was just h squared, is equal to pq squared. Now what?
Sub in them numbers.
There's no numbers to sub in.
Oh.
There's no numbers to sub in. So
Whoops, sorry.
square root the other side. Okay, so square root of 4 pi squared r squared plus h squared equals pq. Did it ask me to simplify it down? No. Would it be acceptable to leave it like that?
No.
I think it would.
Just in case you want to simplify it.
Just in case, how would I simplify it? You've got to be really careful with this bit.
You simplify by doing 2
Could you? Sorry.
2 pi r.
2 pi r.
No,
Could you?
you would if this sign here was a times, but it's not. So let me demonstrate that over here. Okay? If I said to you 3 squared plus 4 squared, square root it, would that be the same as saying 3 plus 4, which is 7? Is the answer 7?
No.
But does that not look correct, what I've done?
It looks correct.
Yeah,
It looks correct, doesn't it? What is 3 squared?
9.
9. What is 4 squared? What is 9 plus 16?
Some big number.
Root 25, which is 5. And that one is definitely correct. It's this one that's wrong. It's when you've got a plus in the middle, you've got to be really, really careful that you don't just say, oh, they cancel out. They don't. They do if they're timesing. So if I had something like 3 squared times 4 squared, and then said, right, that's going to be 3 times 4, which is 12. What is 3 squared again?
9.
9 times 16. What's 16 times 10?
160.
What's 60? Take off 16,
That would be 100 and...
which is 12. It does work when it's timesing, so that's fine when it's timesing, but it doesn't work when you're adding. So the fact I've got an add sign there, I don't even want to go anywhere near it. I'm just going to leave it well alone. Okay? All good? I think that's the final answer. I'd be surprised if Mark says anything different. Yep.
Can you do the square root of 4 open bracket pi r plus h close bracket squared?
No, because the 4 isn't common in everything, is it?
Oh. Oh no.
I did think so. If 4 was in both bits, that would be fine. It wouldn't be an issue. If it's like in the h as well, that'd be a really good idea because then you could cancel that down. Okay? Okay then. Oh, sorry,
I
Jake.
got 2 pi r plus h. Would that be incorrect?
I believe that's incorrect. Okay, I do need to check the mark scheme, but my gut feeling is, because of the point I just made, that it should be that. Okay? Number 7, QWC. Anyone confident enough to do that? Oh, Ruth, up you come. Number 7. If you want to bring up yours and talk us through your answer rather than write it all out.
I'll write it out and then I'll like.
I said you should take pictures of that.
Oh.
I just said
Oh, camera.
Ruth, are you camera shy?
Yeah.
It's not even pointed at you.
I have to put my face under it now. I'm just looking for the page to worry.
Not a problem.
I just feel like I should put my
If
face.
I were you, yeah, I think you should just stick your paper down there and talk us through what you did.
Oh,
Okay?
Okay.
Just get it there.
Oh, are you sure?
Perfect.
Because
Yeah,
okay.
perfect.
All right. Okay. Right.
Go on, Ruth.
Thank you. Right. Okay. So you read the question, blah 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 blah, and you look for the key things. So like the salary of 1,700, you know, and he receives a bonus every year.
17,000.
And then you look what they're asking for. So like saying 2,500 a share between the ratio of 2 for 3. So you work that out. So 2 plus 3 because you want to plus them, and that's 5. And then you divide what they're sharing. So that'll be 2,500 divided by 5, which is 500. So then you times the 500 by the 2, which would be 1,000. So the ratio would be 2 equals 1,000, and then it'd be 3 times 500, which is 1,500.
How wicked. Right, and then the next question is, or a sum of money equal to 6% of a salary. And I don't know about you, but I can't work out 6% in my head. So
no, you shouldn't be able to. You should need to do it in steps.
unless you're called Einstein, you can. So basically, you write 6% at the top or at the bottom, wherever you fancy. But it's better if you do it at the bottom because you can add them all up and it'll look all cool. Anyway, should we work out one? Hang on. Right, yeah, right. You work out 1%, yeah. So 1% of 1,700. So 10,000, 7,000. Oh. You know what I'm on about.
Well, you know you can do it. You can see you would have.
17,000. That's the word. Right. Okay. So 1% of 17,000 is 170 because you know you to whack off the 2. So
You take off the 2 zeros. Mathematically, you manage to divide by, yeah?
and now you work out. So that'll be 1,170. And then you work out 10% because if you want to have 10%, you can divide it by 2 to make out 5%. If you
Why don't you just times the 1% by 6?
no, it's just
You
easier.
can do this. There's loads of different ways here, but your way is absolutely fine. Finding 5% I think is really clever because then I'm assuming you're going to add those 2 together.
Right.
Yeah?
So let's be
There's
more.
loads of different ways.
Okay.
Right. We're not all like you, so we can't just do 6% in our head. So we're going to divide it by 10. Divide it by 10%. So that would be that 1,700.
It's fine. We know you can do this.
And then half of 1,700 is 850, which is 5%, because half of 10% is 5%. Yeah. Okay. So then you work it out that 170 plus 850 equals 1,200. So if you
Are you sure on that bit?
I don't know, I was really tired.
Zooming in now to have a really good look. I think this bit's wrong, but I'm happy with all the working that got to it. I don't think it's 1,200.
Right, can you tell me what it is?
Okay, 0 and 0 is 0. That's 12. So you carry the 1, then you're going to get 1,050. 1050. Change that. Right, 1050.
1050. Okay.
Oh, 20. That's my fault. That's my fault. Change that 5 to 2.
Okay.
Oh, right, then that's obviously what's happening. It's just slip of the mind. That happens all the time.
Okay. Alright, and then, so basically, what you want to do,
That's quite nice.
so what you want to do, right, is, it's like if I zoom out a little so you can see my numbers, right, so what you want to do is get the total of his ratio and the total, like, you know, so the 2 and the, yeah, and then you'll do 1,020, take away 1,000, which is, yeah, that's it, 20. So that is, so you've got to write out because it's QWC and they like you to write words.
That's
So
a very good point you do.
It's WJEC, you know. You write English and maths. So David should accept 6% of his salary as it's £20 more than the share of 1,500.
If you're there, do you want to sit down? I'm going to just go and show you how I mark that then as an assessor. Look at that. Okay, I'm going to treat it as if it's the correction that was there the whole time, and I can tell just by looking at this that this is going to be certainly at least 1 mark as soon as I look at it. How can I tell that? Any ideas? How I can tell that?
It's structured.
Yeah, it's structured. There's lots of maths going on. And it's really, really clear. The only thing I might be a little bit reserved about giving it 1 mark. It does not require one of the QWC marks, okay? It does not require an awful lot of work to get this up to a definite, not even questionable. All I'd like to see to make this into a proper QWC answer is I'd say add ratios together. Divide by this number. So it's not like it's a ludicrous amount of extra writing, but just explaining what your steps are. But the fact you're using pound signs here, that's fantastic. They're looking for that. They're not looking for 1,000, 1,500. It was pounds. Make sure you've got pounds. Probably, on the whole of it, judging them by this this little sentence here, David should accept 6% of his salary as it is £20 more than the share of the ratio. I think that swayed it for me. Yeah, I would give that QWC 2. Okay, but you could have just made it that slightly easier, so I'm not even having that debate with myself, that if you have little arrows telling me what you're doing, why you've done it, then it's not even up for debate. Okay, so the pound signs, anything like that. If they're using a currency, if they're using a weight, make sure you use those units the whole way throughout the question. Excellent, Ruth. Well done. Okay. Okay, so going back. Which one are we on? Going back now.
We are on 7. Oh,
Oh, we're doing quite a bit of this now.
yeah, we just did 6.
You alright there, boy? Oh, good.
Hey, we're in the middle.
No, we're not. We're on 9.
We're going back and forth, aren't we?
No, we're on
12.
Oh no, we did the other graph.
Okay then, 5, 4, 3, 2, and 1. I'm really pleased this question's come up because someone asked about it on Edmodo. They said about changing the subject of the formula, and this is a reasonably tricky one because it's worth 4 marks. Okay. Thank you. You might get a couple of them at the start of the paper, which are only worth 1, maybe 2 marks, and they're pretty straightforward. This one is anything but. What does it mean when it says make E the subject of the formula? Yeah, E equals, okay? E on its own. Issue, you've got E on the top and on the bottom, okay? The way you start this off, I'd expand that bracket out, but maybe before I do that, I would take over everything on this side over to the other side to get 5 minus E there, okay? Now I'd expand out the brackets to get 2D plus DE is equal to 15 minus 3E. Okay, now I'm going to get E's all on one side because it says make E the subject. I want the E's to be positive, so this is a minus 3E, so I'm going to move that over to the other side so I know it will become positive. So that means I'm going to move everything that's not got E from this side over. So I'm literally just going to swap their 2 sides. So I'm going to get positive 3E plus DE is equal to 15 minus 2D. Now, how would I get E on its own here? I'll give you a clue. Kellen's done something very similar to it already.
Divide by D.
Not divide by D. You've basically done this bit already. How do I get E on its own here? She did it earlier on her question when she came up. What'd she do? She factorised. You pull an E out by here, so that'll become 3 plus D. And then I'm going to take that times by 3 plus D over to the other side, and it becomes divide. Do I need them still in a bracket? In a bracket up by here. Does the bracket need to be there?
No, not times it by.
Yeah, you're not times it by anything. You can if you want. If you just think, well, they're by there, I'd like you to have there. It's fine. You don't need to. That's why I put it in green. Okay? All good? Ben?
If on the bottom you've got minus 3 minus D, that's like D.
Yes, that should be fine, but I think your signs on the top should swap round as well. I think you should have 2D minus 15. Have you got that?
Yeah. 2D.
Yeah. So what Ben's making the point there is he's got literally all the signs are opposite. So he has got minus 15, positive 2D, and then a minus 3 and a minus D. That is absolutely fine as well, because effectively what's happened is every part of that has been times by minus 1, and because every part of that has been times by 1, it is still equal. Okay? All good? Happy days? And then the other 2 earlier parts, 12a and 12b. Factorising, so we're looking for a pair of numbers that add to minus 4 and they multiply to minus 21. 7 and 3, they're the only numbers that times to 21 apart from itself, 1 and 21. Because it's a minus, times is to a minus, so you've got to have one of each sign. So it could either be plus 7 minus 3 or plus 3 minus 7. Which one is it?
Plus 3 minus 7.
Because it makes minus 4, plus 3 take away 7 is minus 4. So what I do now is have x bracket, plus 3 goes in one, minus 7 goes in the other, and that equals 0. What do I do next?
Isn't it just x equals minus 7, or x equals plus 7, x equals plus 3?
X plus 3 is equal to 0, or x minus 7 is equal to 0, because those 2 numbers are times by each other to make 0. And what 2 numbers times each other to make 0? Well, either this one's 0 or this one's 0. That's how that happens. So then, take the plus 3 over, it becomes minus 3. Take the minus 7 over, it becomes plus 7. And if I chuck that in, I can work it out. 7 squared is 49. Minus 4 times 7, so minus 28, minus 21 is back to 0. And again, if I chuck the minus 3 in here, it should do the same. Okay? This one here, I've got a slightly different way teaching it to most teachers. I don't want to confuse you. Do you get all the denominators the same? Is that what you do? Yeah, then I'll do it your way. So you look for a pair of numbers. So I call it the LCM of 2 and 3. What is the LCM of 2 and 3? 6. So you make these all being over 6 instead. So we have over 6 plus something over 6 equals something over 6. What do I do to 3 to make it over 6? Times by 2, so I get 4x plus 6. What do I do to 2 to make it 6? Times by 3, so I get 12x plus 3. And then what do I do to 2 to make it 6? Times by 3, 40 times 3? 120, then times the 3 would be 9, 129. Now because they are all over the same denominator, I can effectively times every part of the equation by 6 and it just cancels out all the 6s as they all go. Okay? So from here, I'm going to get 4x. Now, be careful if you've got like a negative here. In this case, we don't, but really that bit's in brackets, and that minus would have to times through the 12x and the plus 3, but it doesn't really matter, the plus. We've got 4x plus 12x, which is 16x, plus 6 plus 3, plus 9 is equal to 129. So 16x equals 120. X equals 120 over 16, no idea, so I'm going to do bus stop division by here. And that doesn't help me at all, does it? Because 0, 0, I'm back to 120. Okay, how are we going to divide by 16? We could divide by 8 and then divide by 2. Or worst case scenario, we could just start writing out the 16 times table down the page.
Is there any chance you could like half them both?
If you halve them, yeah, you could halve them both. What a great idea that is. Halve them both, we get 60 over 8. Halve them both again, we get 30 over 4. Halve them both again, 15 over 2. 7.5. That's much quicker. I love that way. Ruth, excellent. Well done. Okay? All good? Anyone want to come up and do the flower bed question for you that Martha's doing? Come on then, Sarah. You come.
Don't say things like that. You'll do great.
I'm really rubbish at explaining things.
Sarah.
I'll give you guys 3, 2, and 1. Right, I've just got the time. We've probably got very, very quickly got the time to go through this. But then we finish. Has this been useful exercises on this? Should we try and target the doubles on this and just focus on one paper at a time?
Those are parallel.
Can you see?
So if you have this which in front of you, I'll tell you what, talk through your answer because we haven't got much time. Talk through what you did. Okay, 5, 4, 3, 2, and 1. Nice and quiet, please. Nice and quiet.
Basically,
Guys, at the end of a long day, come on.
basically what I did was that I found out this was a straight line, so took 180 away from 105, which gives you 75. Then I added 75 plus 50, which gives you 125, and then I took that away from 180.
Why?
Because angles in a triangle.
So angles will show back and follow by angles in a triangle.
Then I worked out the opposite of that, which is 55 is 55, because angles opposite at a point are equal. And then I worked out this by working out this, because, what's it called?
Angles on a straight line again.
Angles on a straight line. No, and then you work out this because it's,
Its proper name is called corresponding angles, F angles. It doesn't actually ask for a reason. It never does in GCSE because you use so many different ways of getting there. Well done. So the answer being 55 there. Fantastic today, guys. Well done. We got through loads then.